Hello, everybody. This is Shankar from System Based Labs. Welcome back. So far in this journey, we have explored something very powerful. We started with automation, then we moved into intelligent systems, systems that can read, understand. But now let me ask you something. After a system makes a decision, what happens next? Does it know if it was right? Does it learn? Or does it simply continue executing without awareness? Because in the real world, systems do not operate in perfect conditions. Things change, patterns shift, failures emerge. And this is where most systems struggle. They can execute, but they cannot observe themselves. They can automate, but they cannot improve. So now let us look at a case study, an advanced observability system. This is where we begin to move from automation to autonomous intelligence. Let us walk through this together. At the foundation, we still have execution. RPA tools like UiPath, Automation Anywhere, and Power Automate are running workflows. They are executing tasks exactly as designed. But execution alone does not tell you whether the system is healthy. So we introduce observation. Every action inside the system generates signals, logs, events, transactions, user interactions. Now, instead of ignoring this data, we capture it. For example, we might use Elastic Stack. Elastic allows us to collect and search logs at scale. It helps us identify patterns across large volumes of activity. In another setup, we might use Splunk. Splunk enables real time monitoring. It helps us detect unusual behavior as it happens. And for system level performance, we may use Prometheus. Prometheus continuously tracks metrics like latency, usage, and failures. To visualize everything clearly, we bring in Grafana. Now we can see system behavior in real time. So now the system can observe itself. But observation alone is not enough. Because seeing something is not the same as understanding it. So we move into intelligence. This is where behavioral analytics comes in. Now the system begins to learn patterns. It understands what is normal and it detects what is unusual. For example, using Splunk machine learning toolkit. The system learns behavior from historical data. It can identify anomalies automatically. In another case, using elastic machine learning, the system continuously analyzes incoming data streams. It detects deviations without needing predefined rules. Now something changes. The system is no longer reacting, it is anticipating. But detecting a problem is only the beginning. The system must now decide what to do. This is where decision systems come in. We might use Camunda. Let's see how. Camunda orchestrates workflows. It defines how the system should respond to different situations. We may also use Drools. Drools applies business rules consistently and transparently. And in event-driven environments, we may use AWS step functions. This helps coordinate actions across systems in real time. Now, decisions are no longer static. They are dynamic, context aware, and adaptive. But there is still a gap. Humans need to understand what is happening. So we introduce language intelligence. Using OpenAI, the system can generate clear explanations. It can describe issues in simple language. In enterprise environments, we may use Azure OpenAI service. This brings the same capability with security and compliance. And to connect intelligence with workflows, we use LangChain. LangChain enables reasoning across data, models, and systems. Now the system does not just act, it explains, it communicates. It supports decision making. And finally, we bring humans into the loop, not to operate the system, but to guide it. Through dashboards, alerts, and monitoring tools, humans can observe behavior, validate outcomes, and intervene when needed. Now let us step back. The system executes, it generates data. That data is observed, it is analyzed, anomalies are detected, decisions are made, actions are triggered, and outcomes are explained. And over time, the system improves. So, what does this mean in practice? It means issues are detected much earlier, often before they become critical. It means downtime is significantly reduced because the system can respond immediately and sometimes even correct itself. It means systems become more reliable, more stable, and far more intelligent. Now, where does this really matter? This becomes critical in large enterprises. It is essential in financial systems, where even a small failure can have serious consequences, and in healthcare platforms, where reliability is not optional, it is absolutely critical. So, here is the truth: systems that only automate execute, but systems that observe and systems that learn evolve. And that is the foundation of autonomous intelligence. Now, so far in this journey, we have built intelligent systems, systems that can observe, analyze, and respond. But now comes the next evolution. We move from systems that react to systems that act with intent. In the upcoming videos, we will not just revisit agentic AI concepts, we will bring them into real systems. We will take everything you have already learned: memory, guardrails, tools, reasoning, and orchestration, and show you how to embed them into production grade architectures. This is where automation becomes autonomous. This is where automation becomes autonomous. This is where systems stop waiting for instructions and start operating with direction. We will explore how agentic AI integrates with enterprise workflows, how it works with RPA, and how it transforms decision making systems. So you are not just learning agentic AI, you are learning how to build with it. We will see you in the next video. This is Shankar from System Based Labs. Good luck and goodbye.